Good day, I am Laurence L and I will be talking about the transient dynamical properties of an MM1Q system for different traffic intensities. My advisors are Dr. Cesar Saloma and Dr. John Robenta. Queues are ubiquitous in many types of systems. You can observe them in checkout lines of groceries, in vehicular traffic systems, and even in queues of packets of data in a computer network. Queue problems are often solved using theoretical models that provide steady-state solutions. These solutions are solvable and for most of the time applicable in certain situations. However, experience tells us that actual queues have finite and short lifetimes, that their transient behaviors become crucial. In our study, we simulated an MM1 queue system and analyzed the transient behavior of its waiting time curves. The MM1 queuing model is the simplest stochastic queue system, which is composed of a single server and a single queue with a first-in, first-out policy. We calculated the mean and variance waiting times of all agents and plotted against their time of arrival. We observed that for higher traffic intensities, ρ equals 0.7 and 0.9, the steady-state mean waiting time is not reached within the operating hours. This hints us in a possible critical point from lower traffic intensities to higher traffic intensities. To find this critical point, we fit a logistic function of the form shown in equation using the Levenberg-Markov algorithm. What is interesting is that the exponent n changes the behavior of the curve depending on its value. Based on previous analysis of this equation, we can say that in the context of the queuing system, lower traffic intensities have exponent values of n greater than 1, and high traffic intensities have exponent values of n less than 1. The transition point occurs when the value is n equals 1, which we call the critical traffic intensity. This result is useful enough in determining the state of a queue system. Given only the service and arrival rates, we can then determine the limit at which our system becomes inefficient. Thank you.